Hello all. Today in this video, I'm going to download the earthquake ground motions from the website which is called Pacific Earthquake Engineering Research Center, and let me go to the website. We can type here NGA database. The earthquakes the time history ground motions are required to do time history analysis. Either it's a linear or non-linear time history analysis, so that we can download the required earthquake ground motions, which is according to our site response spectra from the Peer Ground Motion Database Center. So let me click this one. Here we see the windows of your ground motion database, and we have the option to free sign in. So we can sign in here. Okay. So I have already signed in with this account. And here is the option to NGA West to shallow crustal earthquake in active tectonic regions and NGA East. Remember that NGA West to this box, this uh, type contain the earthquakes of all types recorded from all over the world. So it is better to choose this one because NGA is inter this NGA is database is the earthquake ground motion characteristics recorded from the Central and North American region. So better to go to NGA West to Center for our region. So if we are in that central region, it's better to go for East. And for now, let me select the West. Here, before going to downloading, we have the option to enter the target response spectrum. So we have the option here, no scaling, peer NGOS to spectrum, user defined spectrum, or ASC code spectrum. Okay. So uh, the time histogram motions can be downloaded in according to these four types. If we click the no scaling, we can download the raw ground motion, actual ground motion data, and after downloading that raw ground motions or actual ground motions, then scaling can be done according to our site response, specific site response spectrum. So no scaling indicates the downloading of actual ground motion. Similarly, if we upload click appear in GeoWest to spectrum, that the ground motions which are scaled to this spectrum can be downloaded. And if we define the user response spectrum, suppose for example we have the NBC 1052020. If we enter that spectra response spectrum of NBC 1052020, similar type of earthquake ground motions scaled to that spectra are downloaded after we selecting this user defined spectrum. So this is the convenient way to select the earthquake ground motions according to our site. And another one is the ASC code spectrum. We have to give the parameter like STS, SD1, and long time transition period for ASC code spectrum. And for user defined spectrum, we can download the example file from here in the form of CSV file and again upload by keeping this format with the information of our specific site spectra. Okay, so if we see this, let me save somewhere in the desktop. Okay, so here, yeah, this is the site spectra. If we plot this one, plot this one, we can see the spectra of this type. So looking into NVC 1052020, this is not actually this type of earthquake. So we can edit the data according to our response spectrum and again re-upload in the website here. Okay, then after that we start downloading with the scaling to that spectra. Okay, so today in this demonstration I will go select no scaling. So let me click submit. So this window appears. Here are some criteria to search the earthquake ground history, time history ground motions. The first one is here we see the record characteristics. We see the RSN number, record sequence number. If we know the record sequence number of any earthquake, we can directly input here. And another one is event name. What is the name of the earthquake and where is the station? So from this three name or either any of these three name, we can search the earthquake here or here or here. If we know the station name or if we know the event name or if we know the record sequence name, the earthquake can be searched. And other search parameters, this parameter includes the type of fault. Okay, what type of fault? Yeah, if we see here, the fault is all types: strike slip, normal or oblique, reverse oblique, normal or strike slip, sorry, strike slip plus normal, strike slip plus reverse, or normal plus reverse. So, what type of faulting mechanism we need? We can click that one, this one, and search here. Okay, so suppose for now, let me click for strike slip, and another one is the magnitude. We can give the magnitude, suppose let's say 5 or 6 to 8 magnitude, and we can see the data from minimum comma maximum. It means 6 comma 8. 6 is low range and 8 is the higher range. Similarly, we can see the two distance RJV and R rupture, which can be input as minimum and maximum with the comma separation. So R rupture is the closest distance to rupturing fault plane, okay, and RJV is the closest horizontal distance from the side to the projection of the surface rupture. So suppose let me give 30 to 50. Here also let me say 30 to 50. Then this one is velocity. Say let me select the velocity for 10 to 400 meter per second. So here Vs30, which is velocity meter per second, is defined as the average seismic shear wave velocity from the surface to a depth of 30 meter. Okay, so it is very important parameter to characterize the site response for earthquake resistant design and implementing the building code uh, worldwide. So, for example, if we have uh, the structure to be built in certain uh, zone or certain specific zone, and before doing the structural analysis we have to first investigate the geotechnical status or geotechnical site investigation, so that we have to conduct soil penetration test SPT. So if the shear wave value of that uh, uh, site obtained from the SPT, or if the number of penetration number of uh, penetration or SPN number is greater than 50, suppose let's say 50, then the structure have to be designed, the site response spectrum has to be obtained with the procedure obtained from uh, shear wave velocity. Okay, so uh, this is very important parameter in probabilitics seismic hazard assessment. So we should be concerned while selecting this BS30. So here I am going to select 10 to 400 range. So if the n value or bounds number is greater than 50, and I read many literature, so you have to go for the approach of zero velocity to find to calculate the specific seismic hazard spectrums, unified hazard spectrum or response spectrum of the site, and after that, uh, after finding that response spectrum, that will be applied in the analysis. either it's a linear or non-linear analysis. Okay, so it is a very important parameter. Similarly, we see d5 to 95 second. It means that the uh, uh, earthquake energy which is dissipated in between this 5 percentage and 95 percentage of the selected second here. If we give the range of, for example, suppose if I give the range of 20 to 100 in between this 80 second, so 90% of the energy, earthquake input energy, should be dissipated within this time frame. Okay, so or 90% of the earthquake energy should be concentrated within the selected range within the 80-second time frame. Okay, so this is also an important parameter for the selecting the earthquake ground motions. Similarly, we have the option to select the type of earthquake, either it's a false type or no pulse type or only pulse like record. So we have the option to choose the pulse type characteristics of the earthquake. So pulse type earthquake is expected at near fault ground motions. So this pulse type ground motions has one peak like this, and rest of the other amplitude is very low. So this peak pulse type characteristics is prone to damage the structure in a very less number of hysteresis cycle, because the velocity of this pulse type earthquake ground motion is very high, and it can significantly damage the structure. So uh, while doing nonlinear analysis, first of all, we have to select, it is better to select the pulse type earthquake ground motions rather than non-pulse type earthquake ground motions. We can select both types and make a group, for one group for pulse type, another group for far fault or no pulse type, and we can see the significant difference in the result and the damage status in due to the pulse or impulsive type of earthquake. So that we have to do the analysis on the basis of that. For now, let me select the pulse only type records, and another additional characteristics is the maximum number of record which should be less than 100. So for now, let me select 50. Here another option is sweet option, which we can see the spectral coordinate, damping ratio, and sweet average. Here are the options for uh, coordinates for SRSS for X and Y response spectrum, or we can take the uh, rod D100 and rod D50 as well as geomean only H1, H2 direction or vertical. But now we are using the no scaling option, so no need to select this uh, site. We do not have any significant impact because we have done the no scaling. If we have chosen the scaling, or if we have input the user's response spectrum or specific site response spectrum, we have to select these options such as spectral ordinate, SRSS, H1, H2, V, and another one is damping ratio. Generally, there is a damping ratio of 5% and the sweet average of arithmetic or geometric. For now, we have selected the noise scaling options and no need to know any significant effect of this sweet. Okay, so after this, let me click OK. Here we see the source record. Okay, we'll see the see the window here. Source was successfully created. Please allow time to render the graphics. Okay, we can see the graphics here after some time. Yeah, we see the graphics here. Here is only one earthquakes has been displayed with the search criteria we have entered. Okay, so it is on scale spectra, all record SRSS. We can see here the linear one for better understanding. So select let me modify the criteria in order to have more earthquakes. Suppose let me give 100 and let me search record. Let's see how many earthquake will be displayed here. The search has no result. Okay, so here suppose if we change the search parameter criteria instead of only strike slip, let me select the all types and go only false type record and search here. We can see I think more earthquake. Okay, yeah, we see the six six number of earthquake. We see here the data of the earthquakes as six number, and we can download this option, download this earthquake and see the result. Okay, so here we can see the result ID. There are numbers, six number, then spectral coordinate SRSS, then the record sequence number. We can see the record sequence number RSN, the RSN of each earthquake, then the scale factor because we use the unscaled option. So here is the scale factor of only one, and this is TPS and D5 to D75 second. Another one is D5 to D95 aerial intensity event, the year, station, magnitude. We see the mechanism, then RJV, RRAFSA, BS30, and the lowest usable frequency, initial search scale factor. Then we see the H1 acceleration, S2 acceleration, it means acceleration in x and y direction. Then another final one is the vertical acceleration. So if we select these, if we select and we have the options to download these earthquake ground motions. The first one is to download search results, metadata plus spectra, and another one is the download search time series record. So it is better to click this one because all the information can be obtained with this download. But from this download search metadata plus spectra, we can download only the response spectrum of this selected earthquake. So for now, let me select this download all the time series record. Okay, so let me keep somewhere in the desktop. Yeah, desktop. Then we will see the download data. Okay, yeah. Here, if we click this one, then we see the RSN record sequence number 838 lander 000, which one is acceleration, displacement, and velocity file. And for this one is for one direction, and another one is for 90-degree. Another direction, similar file, acceleration, displacement, and velocity. And for vertical earthquake, similarly for other earthquake, for other six earthquake or other five earthquake, the data are in the form of this type acceleration, displacement, velocity for horizontal and vertical earthquake. So if we randomly click one acceleration file for horizontal direction, we see the type of the file here, and we see the fear NGA strong motion database record. The earthquake name is lender, event name, year, and the station, and the acceleration time is to series in the unit of G, and number of point are 2000, and the time interval is 0.02 seconds, and we see 1, 2, 3, 4, 5 column of acceleration record. Okay, so we will use these time history ground motions for nonlinear or linear time history analysis. Till then, in the next video, till then, keep watching. Don't forget to like, comment, share, and subscribe my YouTube channel. Thank you.